Hi everyone, we are back with continuous Fourier transforms. One of the things I wanted to say about this frequency spectrum is our lowest frequency on this frequency spectrum will always be our fundamental frequency. For continuous Fourier transforms, that will be basically our maximum frequency. Frequency is equal to n times delta f, our fundamental frequency. Lowest frequency is equal to delta f. And then finally, our dominant frequency will be the one with the highest amplitude. So here we clearly see it is the first, or our fundamental frequency. So you can do a similar process that we showed last time with other functions as well. So I can have functions that vary as a function of time. And we can see here this is a periodic function. It repeats over 3, and we assume we're going to continue into infinity. And we can just integrate these, perform our same analysis, and you can develop a frequency spectrum as well. And then again, you could see with some harmonics and then values here. Now, how can we visualize a Fourier transform? And especially, I think it's easiest to do if we have kind of a function that's in 2D. So let's look at a function, a complex function, something like this. And we want to visualize this in basically inverse reciprocal space. So let's take this function that varies as x and y, and we could do a Fourier transform. So the way that this syntax works is give me this function that is a function of these variables and plot it instead as a function of these two new variables. And these would represent essentially the frequency space, or that reciprocal space. So this would be my Fourier transfer function, and then now we see. And this is a nice visualization of what is a Fourier transform in general. It's essentially flipping this and plotting, this inverse space idea. So whereas we saw a hole here, now we see kind of this peak. So we can kind of visualize that in 2 dimensions as well. So I think it's a nice idea. So this is finishing up essentially our rough concept of continuous Fourier transforms, dominant frequency, maximum frequency, lowest or fundamental frequencies, and now we're going to move on to discrete Fourier transforms, which is the scenario that you're going to see much more often in this course. So see you next time. Thanks. Bye.